Hi everyone, Kurt with Hypnodyne. Today we're going to take a look at some respiratory events. All of this data that you have in front of you, this was taken with the ZMax with the external nasal sensor. And we also have all of the feature tracks that are extracted when you run an auto scoring on the recording. The new stuff, the new parts are right here in yellow, blue, and gray. So I'm going to go over what they are in a second. But first, this is the first time you've seen the software. That's the hypnogram from the auto scoring. Below that in the background is the spectrogram from the EEG data. And then these tracks are the SpO2 value for the segment shown on the screen, which currently is 480 seconds. These two yellow ones are the airflow for the left and right nostril. The green ones are the accelerometer inclination, so X, Y, and Z. And this in red is the PPG data. You can see it better if we zoom in so that it actually looks like PPG signal. We're zoomed out because we want to see breathing events, so they happen at a larger time scale, on a larger time scale. And this is the noise, which indicates the amount of snoring in gray. And here's the same one as above, but the difference is this is showing you the whole recording, and this is showing you the area on the screen. And you can switch back and forth. There's a specific button for that. And here in this case it's useful to have both. Now finally here is what the software calls HR bad. That is this guy. And that is just an indication of which areas contain malformed or unreliable PPG data. And we needed, the only reason I wanted to have it is to show that this region here on the SpO2 track, even though it seems like it contains desaturations, is actually not valid because of this. Because in fact here is before the patient went to sleep, so it's simply a lot of noise and interference. But this one, for example, this one is a legitimate area that contains a lot of desaturations. So is this one. And finally, so is this one. There's a lot going on here. Maybe I should close some of the signals. Maybe we can close this one. First of all, you might want to visualize the head position instead of the hypnogram. And you might want to know that you have segments like this one over here with a lot of events, and then you have an area with very few events, and then you have an area with more events. And interestingly, the head position when the events occur and the head position when the events don't occur are different. So if you move there, but you need to zoom in a little bit, you can see what that corresponds to. It corresponds to this head orientation that is looking up. And here once again, looking up. But in the middle, where there are no events, that's looking to the left. These are of course sleeping positions that have an effect on the desaturations. But enough of that. Let's just go back to where we were and actually take a look at some of these labels. These labels are imported as markers, so when you load them, you can see a list over here. You can navigate by clicking on them. For example, if you want to see this one, you just click there, and it appears. Or you click on this one, and it appears. Or you can just move through with your cursor. I'm going to turn off the list. So let's see some events. Here there is an interruption in the breathing, which is reported in blue, followed by an apnea, which is indicated in yellow. So the yellow indicates a specific time. That's why it has the triangle. And that specific time is actually the minimum point of the desaturation. Whereas in blue, you can see that there's a faint blue background. It's like a square. That indicates a time range. So from here to here. That would be the breathing interruption. In fact, it coincides with the breathing interruption that you can observe on the airflow signal. So another breathing interruption right here, and another blue marker right here. Another breathing interruption here, and another marker right here. So what's the difference between blue and gray? Well, simply gray means that both left and right nostrils have a complete blockage, and blue means it's only either left or right. Actually, if you look at the signal in these two spots, it wouldn't seem that that is the case, because of course, as with everything, it comes down to thresholding. So these are cases in which one nostril is completely flat, the other one very, very close to being completely flat, so it could go either way. But definitely when there's only one nostril that's not breathing and the other one is just fine, for example here, you can see the bright yellow is very flat and the orange one is much bigger. Here it's reporting as right channel only. Okay. Let's go back to where we were. And let's see it. So breathing interruption, apnea. Good. Breathing interruption, apnea. Another breathing interruption, apnea, and the same here. There are also some areas in the middle where you can see this is good breathing followed by less breathing. So these are counted as H for hypopnea. So it's actually not a complete stoppage, but a big decrease in the airflow signal. And these are also classified with right, left, or both. And you can also see that in this segment, the snoring sound is decreased, presumably because there's less breathing or an occlusion of the nostrils or something like that. But this amount of snoring that happens during the events is reported as the number. The number doesn't have a unit, it's just something you can use to compare one event to another. And so whereas this one has a 6, just because of this tiny peak over here, this one actually has a lot of sound going on. The peaks are very high, so it says 42, 46. This one is something in between with 36. That's just because it caught this one right here. But let's move on and see more events. Here we have an apnea that does not seem to have a great decrease in airflow. If you look at the airflow right here, there's some decrease, but it's not sufficient for the software to report hypopnea. Otherwise it would locate them all over the place, at least in this recording. So this is not as significant as the other ones, but still there's an apnea. So the apneas, sorry, here I'm getting confused with the terminology. I mean a desaturation. So the desaturations can sometimes happen even without an accompanying decrease in airflow. Now I don't know if that's something that is known in the literature, or if it's just because I'm only acquiring the airflow at the nostrils, but it seems interesting. So this is really the prototypical apnea and desaturation that you would see, with well-reported breathing interruption and the desaturation and a blockage in the perhaps you should call it an interruption in the snoring. You can find some more things looking pretty much the same. Here there's a hypopnea, decrease in the breathing. Let's move to another area. Let's see what's going on here. So here it's very variable, but it's changing slowly, so it's not really marked as an event. I think from 12.191 to 12.212, about 20-30 seconds, but there is an apnea, so it's still a little bit subjective whether you probably should score this as a hypopnea, but that can all be customized. But one of the reasons I chose these particular thresholds is that, at least for this signal, it's just so full of events that I really don't want to have markers everywhere. They tend to overlap as well. So I just wanted to see the most relevant ones. After all, here there's still breathing. Here also could be considered a hypopnea. And it really only detected the last bit when it really becomes very, very faint. Almost no breathing there. And then there's the desaturation in the end. So if you want a complete picture, really look at the signal and you can see exactly what's going on. Like here, for example, perhaps you wouldn't know it looking on at the airflow, but if you look here, you see that there's a definite something that's happening here and here because there's no sound. So these are all interesting things to see. The markers themselves are much more useful if you want to do any kind of numerical comparison. If you want to compare two nights or different subjects or different medications, in that case you really don't want to get bogged down with all these details. You just want to see, as long as it has a constant thresholding, then you're able to compare nights across different circumstances. And there's another prototypical breathing interruption with the apnea. You can see that also this waveform has a particular shape, so even the idea that you're just gonna look at the amplitude, that's not really all there is to it. For example, looking at the strange shape of these peaks right here, I can see that the breathing there was a little bit strange. There might be obstructions in the nostrils that cause the airflow to drop and then to continue. And then there are places where the breathing is a little bit the frequency of the breathing changes. For example, if you look at the EEG here, we have an arousal, and this is where the movement occurs. There's a position change. After the position change, you have normal breathing, then 2 long breaths, then fast again, then a long one again, fast, slow, and then it's much less variable after that. That might be important. The same phenomenon might be important when you're trying to figure out where exactly REM sleep is starting. This is something I've noticed. I don't know if this is the consensus, but I see sometimes that towards the beginning of REM sleep, there are a few breaths that are faster or slower than normal. Probably has to do with nervous system switching gears. I don't know exactly, but it might be useful. I thought I saw an episode right there, but I'm gonna need to zoom in to really see it. Zoom in, but not too much. Say 120 seconds. And this is pretty much where REM sleep should be beginning. And so you have a few shallow breaths right here that are also faster. And prior to that, this is simply a position change. So if I were to interpret this, but I might be wrong, but there's a position change. So the person drops out of deep sleep about half epoch in. So I would say that up to here it was N2 or N3, probably N2. After this it's probably N1, and then here I would say that the REM, if I had to choose where the REM is starting, I wouldn't put it here, but I would put it here, simply because of these strange breaths that happen. But I could be wrong about it. That's just a curiosity, I'd say. So we've seen a bunch of things. Let's look at the last area, see if there's anything different over here. Here again the breathing becomes quite strange. Here it's fast, here it's super slow. And then finally the person wakes up, so that we're out of bounds over there. Left and right nostril breathing interruption. The 9 again represents this peak over here. Perhaps this as well. Now the 9 actually doesn't tell you that much. If you look at exactly how it's spread out, I mean, that's probably probably a project unto itself to figure out a way to represent how these things are spread out and reported numerically. But I would say that having generally flat morphology on the gray signal, that is the noise, with these sudden bursts of sound, that is very typical of when you hear people snoring and their breathing stops and then they have these very short sounds. I should probably close it here. I think we've gone through everything, but See, there's a wealth of data here that could be mined in many different ways. As you see, there's the idea of comparing head positions. So let's say that you figure out that sleeping with your face pointing upwards is really bad. What can you do with ZMax about that? Well, you can create a very short script, very, very easy to do with ZMax, and make it so that as soon as it detects a breathing interruption, which I think the code is already there for this, and you're in this position that's not good for you, namely looking up, then produce a vibration or something that's going to create an arousal during which supposedly you remember to turn on your side. And this is important for people that know that they have a best sleeping position, but they absolutely cannot fall asleep in that position. And that's my case, unfortunately. So I know I sleep better facing upwards, but I can't fall asleep like that. I'll be in bed for hours trying to. So the idea that you can go to bed in whatever position you want, but then have the stimulation occur halfway through the night, where supposedly it's very, very easy for you to fall back asleep because you were sleeping already. That's quite important, not just for people that have a preferred sleeping position, but for people for whom specific positions are actually really bad. And so that's one thing you can do. Another thing that you could do is look at where these episodes happen with respect to the hypnogram. So it seems to me from this recording that this person has a lot less breathing events during the deep sleep. I'm not sure if that's very significant. And another thing that you can do, if you've been following the progress with the instant messaging interaction in ZMax, you know that for each data bucket like this, for each recording and all the associated features and hypnogram and all of that, there is a set of user annotations and keywords that the user can enter through their mobile phone. So leaving for a moment alone the fact that of course you can see a lot more detail if you actually look at the signal, but just take the markers, which I would say they're 85% accurate. You can go ahead and make them even more accurate, but they're already a really good indication, I would say. And if you take these and compare them across nights, you can then figure out if there are some specific daily activities or behaviors or diets or medicines or anything, or supplements, who knows, that affect the number of episodes. And that would be really interesting. So one of the points of ZMax is not just to capture a whole lot of data, but to then be able to figure out how the person's physiology is actually working to try to improve things. And general advice is great, but everybody already knows general advice. It's not good if you have a big cup of coffee at midnight, because you won't be able to sleep. But beyond that, we already know that we have chronotypes, and people are not all the same. We have preliminary intuitions from evolutionary biology about why we might have staggered sleeping cycles, which I think I mentioned in another video. But individually, what works for you, what affects things for you, it's never been really possible to study that. And nowadays we have these buzzwords going around: personalized medicine, which is great, and big data, which is also great. But with a puny price of one ZMax, one nasal sensor, and perhaps a software license, you can then acquire an enormous wealth of data, an enormous amount of data that is not just personalized, but also big. So that is the intersection, the merger between big data and personalized medicine. I think if you were to wear ZMax for a year, it would yield 73 gigabytes of your sleep data. And honestly, I don't even think AI is needed here, because if you record a bunch of days, especially throughout the seasons, that's why I often mention a year, which might go beyond the tolerance of most people, but a year is nice because you can see all the seasons. So if you have that much data, if you just look at the 10 best nights that you had, and you realize that you're doing something specific that you're not doing on other nights, that's already priceless advice, because you have to take into account the fact that effects might not be immediate, and effects might take several days to show up. That's the same for allergies and and digestive problems. So if you do a specific thing and then that night you sleep well, that's something that almost everybody can realize. But if you did something right 3 days ago and today you slept well, then you wouldn't really know. And if you've been doing it with a slightly higher frequency throughout the past month than throughout other months, and it starts affecting your sleep, that's also very hard to detect. We're good at detecting patterns where the effects happen immediately, and it's much more difficult to detect patterns when the effects are not immediate. And that's why having all this data, even without AI, but of course if you have AI and you're doing pattern recognition on the activities, it's even more useful, that then you can seriously begin to think maybe we are reaching the point where a wearable can actually help you to improve things, as opposed to just repeating what you already know, that you didn't sleep very well. And the stimulation just adds another layer to all that, because I suppose, and we're about to test this actually with this particular patient, but we're about to test the stimulation features that I was describing before, where since there's a substantial delay in the lowest point in the apnea with the beginning of the let me use the right word. There's a substantial delay between the beginning of the apnea or hypopnea and the bottom of the desaturation. Since there's this delay, of course you have sometimes 20, maybe even 30, 40 seconds to intervene. You would intervene right here. It takes the algorithm about 5 seconds to detect that you're not breathing. So you could stimulate right here, trigger a position change, and you wouldn't have this. And just in case you're wondering, this is 88. To get to 88 SpO2, you're really about to choke. It's very, very uncomfortable. You can try that with a finger oximeter. So, and look how many. Imagine removing from this patient, how many are they? I don't even know. I haven't counted them, but looks like he has several dozen episodes. Imagine that all the things in yellow get removed or partially removed. Let's say we remove 70%. That cannot possibly not be a better night's sleep than what he was getting before. All right, that's all I have for you for today. If you have any questions, you can comment below or contact us through the website. It's as usual, hypnodynecorp.com. The link is below. Thanks for watching.